Hey class, for this lab, we are going to be doing force, velocity, and power. So how we're going to do this, one group at a time is going to come with me into the lab, and we're going to hook you up, just one of the individuals in your group, to the Isokinetic Dynamometer. And it really won't take that long to acquire all the data. I just have to input some information about you, like your height and weight, and that's approximately it. And then we'll hook that individual up to the Isokinetic Dynamometer. And what the Isokinetic Dynamometer is, I think everyone has seen in the lab. It's pretty much the largest central feature of the lab next to the treadmills. And what it does, we can program it to hold a angular velocity constant, so the amount of degrees per second, so effectively speed, how quickly you're moving a joint or a limb, and the dynamometer measures the amount of force that an individual applies at a given speed. So there's a lot of stuff that we can do with this machine. So say you injured your knee. We can measure how strong you are at a slower speed and how strong you are at a faster speed. So typically individuals recover strength at slower speeds sooner than they recover strength at faster speeds. So if someone is going through rehab, we can measure that and we could inform them. Other things we can do, we can see what the relationship between your quadricep and hamstring strength are, and numerous other muscles, bicep, tricep, all sorts of things. But in lab, we're really only going to be doing the most common one, which is knee extension, knee flexion, so quadricep and hamstring. And we're going to be measuring one person in your group, their force output at slower speeds and progressively increase the speed, and we're going to see the force-velocity relationship of this. So typically a force-velocity relationship looks approximately like this, inversely proportional in a way, that as velocity goes up, force goes down, as velocity goes down, force goes up. And I think this makes intuitive sense to anybody with if you ever lift a really heavy object, typically we lift it slower than how we would lift a lighter object, at least if you're giving maximal effort. So hopefully everyone gives maximal effort in class today. Now, we can measure where someone's peak power is over the course of percentages of their max force output. And something really interesting here is there's actually a difference in fast twitch versus slow twitch muscles. So typically, faster twitch muscles have a slightly higher percentage of like where their peak power is relative to like what their force is. So here's a general example. Like a slow twitch muscle would have its highest power output at say 30% of its max force output, whereas a fast twitch muscle might have its highest power output at 50% of its maximal force output. So today we're going to be comparing quadriceps and hamstrings, and we're going to see if whoever goes in your group, if their hamstring or quadricep is slightly more fast or slow twitch dominant. So hopefully that's fun and interesting to all of us in here. Now, what we're going to have to do, we're going to have to make two graphs and then answer 3 questions overall. So let's look at how these graphs are going to look. I'm not going to give you an Excel file, so go ahead and pause and make an Excel file that looks somewhat like this. I will increase the size just a little bit. So we're going to be doing quad, degrees per second, peak torque, and average power. So these are really the only 2 things that we're going to be measuring during the Isokinetic dynamometer stuff. And these are the degrees per second that I'm going to have programmed in the computer. So that's going to stay constant. Go ahead and write all that in. So 15 degrees per second, 30, 60, 120, 180, 240, 300, and 360. So really how this is going to look, fairly slow, all the way down to 360, which is going to be really fast. And the graphs that I'm going to expect you to make, I'm just going to make up some hypothetical numbers right here that you can enter these in if you want, but we will be measuring whatever the individual in your group actually does. So here, just to make everything look clean, I'm saying that here are some torque numbers. So 350, and it's progressively going down as the speed gets faster. That's kind of what we expect. Now, it might not look like this in lab. And then average power, it's going to likely start a little bit low and then peak somewhere in here, and then it's going to start going down a little bit. So what I'm going to want you to do is have a force, velocity, and power curve. So this is how that's going to look. If you just highlight that, we're going to make a line graph, just like that. Let's make those lines go away, and quad. So if we look here, these lower numbers, that's the power. So if I double click on that, then this should come up, secondary axis. There we go. We have that. So all of our data labels, let's just go ahead and put all of those in. So over here, higher numbers, so that's going to be torque in M. Over here, that's going to be power, watts, little w is fine. And then here, this is going to be velocity, degrees per second. Sorry that my cursor is in the way right there. Now, I will want you to alter the x-axis so that it looks a little bit cleaner. So if we go over here, I'm going to do that again. So I just clicked on that. I select data. Then here, edit on horizontal axis, and make sure that it's a line because you can alter this on a line. What I want it to be 15, semicolon, space, 30, 60, 120, 180, 240, 300, then 360. Press OK. There we go. And that is how that looks. That's effectively what I'm going to want this graph to look like. Now here, you should alter those to be torque and then power. So make sure that you're altering all of that to make sense, and you'll just copy and paste that into the Word document. Now, you will also just effectively make another one of these for the hamstring. So there's going to be two graphs overall that you're going to end up doing, and if you just double click on those, you can actually see the rest of the column. Now, one of the questions that I'm going to ask, number 3, is what percent of torque is where the highest power happens. So what percent of maximal torque? So probably here is going to be the maximal torque. So that's the highest. And then if we look over to where the highest power is, it's going to be like right about there. So how we would do that, so that's our highest power. So it would effectively just be that 200 divided by 350 would be what percent So if this was actual data, we would say that this person's quadricep reached their maximal power at around 57% of their maximal force or maximum torque output. So that's going to be how you answer question number 3 and 4 for the hamstring whenever you do it. And the last question, which will be number 5, which one is slightly more fast twitch? It is just simply which one is reaching the highest power at a higher percentage of torque than the other one. So that's more or less everything that we're going to be doing in the lab. Make sure that you have this all ready and be ready to answer the questions. I'll see you soon.